Chapter 8, Section 4, Day 3 works with rational expressions as well. Today we're going to learn how to divide them. So anytime you divide a fraction, remember that you flip the second fraction and change it to a multiplication. So the first one stays the same, 3a to the fourth b over 2a squared c cubed. But I'm going to change that to a multiplication. Put the denominator in the numerator and the numerator in the denominator. Anytime that there are not plus or minuses, we multiply across the top. 3 times 8 is 24. I have an a to the fourth, a b, and a c to the fourth. On the bottom, 2 times 12 is 24. I have an a to the fourth and a c to the fourth. Remember to do your restrictions before you cancel. Here's the tricky part in division. Division restrictions come from every denominator. So that means denominators of the original and this one as well, because even though I had that in the numerator in the beginning, it becomes the denominator and is part of the restrictions. So that means all of the letters involved there are A's and C's, so A and C can't be 0 is my restriction. See what cancels. The c to the fourths cancel, the a to the fourths cancel, so do the 24ths. I'm left with b. Letter B, I'm going to start by rewriting this as a multiplication problem. Keep the first fraction alone, change it to a multiplication, and flip the second fraction. Keep in mind that the restrictions come from both denominators and the numerator of the second fraction. So my restrictions are j and k can't be 0. I'm going to multiply across the top. 6 times 3 is 18. I get a j cubed and a k to the fifth. On the bottom, 5 times 4 is 20. I get a j to the fourth and a k cubed. So if you reduce, 18 over 20 reduces to 9 over 10. J cubed over j to the fourth is a j on the bottom because it's bottom heavy. And k to the fifth over k cubed is a k squared on the top because it's top heavy. So letters C and D, if you look, have addition and subtraction involved, so you're going to have to factor. So I'm going to do 2 steps in one. The first one is to factor the numerator of the first fraction. So that's this one right here. 2 numbers that multiply to 18 and add to -9 are an x minus 6, x minus 3. The denominator of that fraction factors into an x plus 5, x plus 6. I'm going to change it to a multiplication, and I'm going to flip the second fraction. So the x plus 5 that's in the denominator is really going to go to the numerator. And the x squared minus 36 will go to the bottom. X plus 6, x minus 6. Your restrictions come from both bottoms and the numerator of the second fraction. So in this problem, my restrictions are that x can't be -5, -6, and +6. And then cancel what you can. I see a +5 and a +5, and a -6 and a -6. Looks like I'm left with an x minus 3 on the top, and 2 copies of an x plus 6 on the bottom. Letter D. Change it to a multiplication, which means I'm going to flip that second fraction when I get there. If I factor the top, take out a 3x, I'm left with an x plus 1. Factoring the bottom, we start by taking out a 4. That leaves me with an x squared minus 6x plus 9. X squared minus 6x plus 9 can break up into an x minus 3, x minus 3. I'm going to recopy that 4 just so we can see it. On the top of the second fraction, if I start by taking out an x, I'm left out with an x minus 1. Ooh, just kidding. Wrong place. I have to flip that. That goes on the bottom. And the top is an x minus 3, x minus 1. So restrictions come from both bottoms and the top of the second, which means that my restrictions will be x cannot equal 3, 0, because of that x right there, 1, and that looks like it's it. So we cancel. An x and an x an x minus 3 and an x minus 3, an x minus 1 and an x minus 1. Looks like I'm left with a 3 and an x plus 1 on the top, and a 4 and an x minus 3 on the bottom. So the last part of this is the complex fractions. Complex fractions are fractions within fractions. It's just easier to write them as a division in one line and then change it to a multiplication. So if you take a look at letter A, 2/3 over 5/8 is the same as 2/3 divided by 5/8. So we make that a multiplication and flip the second fraction. You would end up with 16 over 15 because 2 times 8 is 16, 3 times 5 is 15. It would be 16 over 15. Letter B, I'm going to work that the same way. It's a over b divided by x over y. But that's the same as a over b times y over x. I need restrictions here. B and x can't be 0. They're the denominator. And keep in mind that that second fraction also contains a denominator. So it's those three. So I should add a y to that. I multiply across the top. That gives me ay. Multiply across the bottom gives me bx. Nothing cancels. All right, for letter C, always start by rewriting the problem first. So the top fraction is an x plus 5 over 3x plus 12. I'm going to change it to a multiplication and flip the bottom. So instead of x squared minus 25 being on the top of that second fraction, I'm going to put it on the bottom. And instead of 3x being on the bottom, I'm going to put it on the top. And then I factor what I can. I can't factor the 3x, and I won't factor the x plus 5. However, the 3x plus 12 will break up into an x plus 4, and the x squared minus 25 will break up into an x plus 5, x minus 5. Your restrictions come from denominators and the numerator of the second. So my restrictions on this one is that x cannot be -4, -5, +5, or 0. Cancel what you can. I can get rid of x plus 5s and get rid of 3. I'm left with an x on the top, an x plus 4, and an x minus 5 on the bottom. Letter D, start by rewriting the problem. I'm going to flip that second fraction because this is really a multiplication. So the bottom, x squared minus 4, will go to the top. And the top, 4x squared plus 4x, will go to the bottom. And I factor what I can. All of these have something they can factor. So I'm going to start with this. Taking out a 2 leaves me with an x plus 1. On the bottom, taking out an x leaves me with an x minus 2. On the top of the second fraction, I break it up into an x plus 2, x minus 2. And the bottom, if I can take out a 4x, leaves me with an x plus 1. Restrictions come next. They're bottoms and the second top. So x cannot be 0, 2, -2, and -1. And then cancel. The 2 and the 4 reduce to a 1 and a 2. I can get rid of the x plus 1s. I can get rid of the x minus 2. I'm left with an x plus 2 on the top and a 2x squared on the bottom. This x and this x together will give me x squared.